All right, so prerequisite skills. These are things that you ought to know coming into this class. Okay, just a little bit of a review. We will review this. We will take time to review some other skills as we need them, like factoring. I find that about 99% of you, when you get into precal, don't factor very well, and that's okay. We'll work on that. Set and interval notation. We use set builder and interval notation in this class a lot. And it's in the first unit, so I thought let's just go ahead and get that out of the way. Have any of you ever seen set builder notation, heard about that before? Maybe, maybe not. No, at least somebody's like, nah, I never seen that before. You may not have. Set builder notation uses those brackets, which I suck at drawing and everybody else does too. They look like little sideways birds. Set builder notation uses scroll brackets, okay? The form of set builder notation is going to be the name of the set equals, and then there'll be a bracket. The variable, like x, a lot of times we're doing the domain, so it's x. If we were talking about set builder notation for the range, we would use what? It's not a trick question. If domain is x, then range is what? Yeah, y. Thank you. So if we were to say the set A or D for domain, maybe we'll change that and say D for domain because you'll see it a lot in this class. You don't have to change it. X is defined as, that's what that line, X, such that. So this is the variable. And then it will give you some sort of inequality. In this case, X is greater than or equal to 2. Comma. This is going to be your function or your inequality. FCN is function. And then it will tell you what set you're using for that variable. In this case, where X is an element of, that little E means is an element of. In this case, Z. Anybody know what the set Z is? Anybody remember? Integers. Z is for integers, okay? Like -1, -2, 0, 1, 2, 3. There are tick marks on the number line. Where X is an element of the integers. So I could actually list the members by reading set builder notation. I can actually list what are the members of this set. I know starting at 2 and going higher than 2. So all the numbers would be 2, 3, 4, 5, 6, 7 on to infinity. Okay? So everybody get what I'm talking about here. All right. So let's do a little practice here. It says write in set builder notation. So we're going to define our set as D. We'll just do D because these are all X, okay? So D equals, scroll bracket. What is my variable? X. Straight line such that. What is my function here? Yeah, X is greater than -3. Where X is an element of, now it doesn't tell me what set I'm using. So what is the default set for numbers? What's the biggest set of numbers there is that we usually talk about? Starts with an R. Rational is close. It's the second biggest. How about reals? Real numbers. Real numbers is R, so X is an element of the real numbers. We usually do double bar R. I'm not going to be picky about the double bar. Okay? So why don't you try B on your own? See if you can write it in set builder notation. Mimic what you've seen. Whew. Oh, by the way, you can have something to drink in here if you want something to drink in here. I'm going to drink. I'm not, hydrated brain is a good brain. So if you need to bring in something to drink, quite frankly, I'm not going to be offended or say anything if you have, a biscuit in here with you too. And no, you don't have to bring me one. Just, as long as you don't make a mess, we'll be fine. Okay? If you need coffee, please. I know it's first block. I have to have coffee in the morning. If you need coffee, bring your coffee. If you're an athlete and you have to hydrate, I'm assuming you're a football player, and you have to hydrate because you have football practice this afternoon or you've just come from football practice this morning, bring your water, your Gatorade, whatever, I don't care. All right? As long as it's not an issue, you're going to find I don't care.
Excuse this interruption. Teachers, at this time, you may begin taking first block attendance. At this time, you may begin taking first block attendance. Let's have a great first day. Thank you.
Chris Garcia? No, Chris? No, Chris Garcia. Okay. Anybody else for this anymore? All right. All right, so let's get back to it. Let's see if you got it right. And sometimes I will wander around with this thing and hand it to one of you and say, show us what you did. Okay, so we're going to start with D for domain is equal to x such that, here's our inequality, x is between -1 and 4, where x is an element of the reals. How'd you do? Easy, isn't it? All right, so now, here is an issue. X is even. Oy. Even implies some things, doesn't it? How do we get an even number? What does every even number have in common? Thank you. They can be divisible by 2. So, and thank you. Yes, it can be divisible by 2, which means that if we double a number, even if it's an odd number, what do we get? We get an even number, don't we? So that's what we're going to do. Some of these you have to think about it. So for this guy, if we're doing the domain, x such that we can't just write x is even. Doesn't work that way. We're going to say x is equal to twice some number. Now we have to define, instead of defining what x is, we have to define what n is. So where n is an element of, are decimals even necessarily? Not necessarily, are they? But, well, they can be, can't they? As long as whatever we have, but we're not going to really think about it that way. We usually think of even numbers as whole numbers, don't we? Like 2, 4, 6, 8, -2, -4. So what numbers would give us those if we doubled them? Which set? We've already looked at it once. Hint. Hint. The integers. Think about it. Aren't the integers -2, -1, 0, 1, 2, 3, 4? So if we double all of those, we get what? We get an even number, don't we? So sometimes you can have set notation where you're not actually defining the x. You're defining something that's going to give you the x. Does that make sense? And the reason I'm showing you this is because we will use that when we talk about domain and range for different functions that we'll be dealing with next. Okay? All right, so let's remind ourselves, this is a good place to remind ourselves what are the different types of sets. N. Anybody know what N stands for? Natural numbers. Do you remember these from like algebra, math? These are the natural numbers. These are numbers you can actually see, feel, count. So that would start with what? Anybody wanted to say 0? Can we see or feel 0? Could you actually pick up 0 things? Natural numbers are like you can physically touch it. So 1, right? This is the caveman number system. 1 mark, 2 marks, 3 marks. 3 rocks. Og has 3 rocks. W stands for what? What's next above the natural numbers? Wow, it's been all summer, hasn't it? Whole numbers. Is any of this tickling your brain at all when I say it? I hope. Whole numbers. Whole numbers is when we got the idea that you could actually not have something. So what's the only number that was added to the natural numbers to make the whole numbers? Yeah, 0. Z stands for integers. And somebody always says, why not I? Well, because it was already taken up before they got to the integers. And integers sounds like Z. So, dot, 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 -3, -2, -1, 0, 1, 2, and so on the other direction, right? Those are all the tick marks on the number line. Q. Q are the rational numbers. These are all the numbers that you can write as a fraction. Okay? So we define those as P over Q, where P and Q are integers. Okay? And Q is not equal to what? What can Q not be? It's a fraction, guys. What can't Q be? What? Yay, thank you. You cannot divide by 0, can you? So Q can't be 0. All right, good. I are the irrational numbers. Irrational numbers. Okay, irrational numbers are non-repeating. Non-terminating numbers. So they're non-repeating, non-terminating. And I always like to give an example of this. Pi is a non-repeating, non-terminating number. Square root of 3 is a non-repeating, non-terminating number. If you take the square root of 3 on your calculator, you're just going to get a list of numbers that goes on forever. E, you'll get familiar with what E is. So like pi and E and the square root of something that's not an integer, like the square root of 3, square root of 2, okay? And R is what set? Reals. They are the real numbers, okay? That is any number that can be written as a decimal. That includes every single number that's in the sets below it, okay? If you'll notice, the way I've written this is sort of like backwards. I started with the smallest set and went to the biggest set. There is one set that's even bigger than this, and we'll get to that eventually. It's the complex numbers, because complex numbers have a real and an imaginary part. So the real numbers are actually part of a bigger set. So the real numbers, any number you can write as a decimal, because all of these can be written as decimals. And that includes whole numbers and 0. Can I write 2 as a fraction or as a decimal? What would 2 be as a decimal? 2.0. So I can write anything as a decimal, even if it's repeating or non-repeating. All right? All right. So, any questions so far? Am I going to ask you to know all of these? You kind of need to know what the integers are. You need to know about real numbers. You need to know what these are, sort of. We'll be doing a lot with P over Q this year. As far as the rest of them goes, those are kind of the biggies, okay? So you need to know what an integer is, because we'll use that as a set of numbers. You need to know rationals, because P over Q is going to be like a thing in your life when we get to rational functions. And real numbers is a set we use a lot. All right, interval notation. You should remember this. I know you had this in Algebra 2, trade, okay? Bracket versus parentheses. When you talk about interval notation, bracket versus parentheses, bracket means it is closed. Okay? Or otherwise known as bounded. And parentheses means it's open or unbounded. You'll notice I will start using, I'm not going to use like goofy little silly language in this class. Some of you are headed to calculus next year, higher level mathematics. So you kind of need to know what that stuff means. Also helps you on things like the ACT. All right, so if something is closed or bounded, we are talking about less than or equal to, greater than or equal to. That equal to is the bounded part. That's what that bracket means, right? It starts here and it includes this. It ends here and it includes this. So open would be the exact opposite of that. Instead of less than or equal to, greater than or equal to, it would be what? There's going to be a long year if nobody answers. Just less than or just greater than. Yes. Just less than, greater than, just less than. Okay? Notice there's an asterisk there that says plus or minus infinity is always what? Is it always going to be bounded or unbounded? Yeah. Why unbounded? Is infinity a number? It's a concept. Infinity is not a number. There is no end to the number line in either direction. If there is no end, then we can never actually get there, can we? So it is unbounded by nature. All right, so how do I write the types? There are 4 different types we can have. We can have fully bounded, AB, starts at A, ends at B, includes both of those, right? That means that A is between A and B. Do y'all know how to read that? We read it from the inside out. Does everybody understand that? When we read this from the inside out, we are saying that X is greater than or equal to A, and X is less than or equal to B. In other words, it is between A and B. If we were to look at this on a number line, we'd have a closed circle at A and a closed circle at B, right? Relate this to what you know. We've got 2 options that are partially halfway bounded. We can have it closed at A and open at B, or we can have it open at A and closed at B. So we could write those as A less than or equal to X, which is less than B, or we can have A less than X, which is less than or equal to B. Last option is fully open. And that would be between A and B, but not equal to. That would be 2 open circles and in between. All right. So how do we write this? Let's look at some of these and let's talk about how do we write X greater than or equal to 2. These are the ones that give people trouble. If it's got 2 endpoints, y'all are usually good with it. But if it's just one number, people tend to do weird things like try to put X at one end and 2 at the other and make a bracket. What does X greater than or equal to 2 actually mean? Where does this interval start?
2.
Thank you. Where does it end?
Negative.
Thank you. Infinity. If it is greater than or equal to, it is everything from 2 up. So this thing starts at 2 and ends at infinity. Now we can add the brackets in. Is it closed or open at 2? See that line right there? That means it's closed. And for infinity, what do we know? Infinity is always open. So that's what our interval would look like. Okay? What do you think so far? Now, Y'all are probably thinking, I can't believe she's making me do math the first thing at 8 o'clock, 9 o'clock in the morning, 9:20 in the morning on the first day of school. But when you're in third block and you're bored out of your mind because somebody's talking at you for an hour, you can pull this out and do your homework. And you'll be like, thank you, Miss Duffy, for giving me something to do. Yeah, I know. Pipe dream, isn't it? All right. Can you write these as an interval? If it's a set, then it needs to be written as an interval. If it's an interval, then it needs to be written as a set. So, why did I give this to you backwards first? Because if you can work it backwards, you can work it forward. So, where does this interval start? Starts at -6, doesn't it? So we start at -6. We're automatically going to default to what in between? X. And where does this thing end? Okay, 3. Now, let me give you a hint. The symbols are always going to go the same direction. From bottom to top, it's always going to look like this. Now all we have to do is figure out if we have to put a line, an equal to underneath any of them. Which one gets the equal to underneath it? The bracket does. So the first one does, the one attached to -6. Boom, easy. Can you do that on your own? Try C. See if you can do C for me, please. We'll come back to B. See if you can go this direction and put it into interval notation. Okay? See if you can go the other way. Where does it start? Where does it end? Starts at -2, ends at 3. What do both ends get this time? Brackets. Easy, easy, easy. Good. All right, so let's talk about B, because B is the one that everybody screws up on. You cannot put negative infinity in an inequality. You cannot put it in at all. You can't just say X lies between negative infinity and -1. It doesn't go there. Where does this interval start? No. Where does this interval start? Well, you already told me that negative infinity is not a number, so can it start there? So where does this interval start? -1. It starts at -1, and where does it go? To negative infinity, which means that from -1, is it getting bigger or smaller? Ah, so it's everything, use your words, less than, greater than, equal to, whatever. It's everything less than -1, isn't it? Do you see how you can interpret this? So how do I write that as an inequality? X is what? Less than -1. Okay, do you see why people screw that one up? Never put negative or positive infinity in an interval. You can put it in interval notation in the brackets, but you cannot put it in an actual inequality, okay? So, do D now. Put D, change it from an inequality to a interval notation. Ask yourself, where does it start? Where is it going? Where does it end? Where does it start? 4. Where does it end? Infinity. Good. Now I heard somebody say 5. You can't start at 5. It could be 4.23333 or 4.0000001. So it starts at 4. We just don't include 4, do we? So what goes on this around this thing? Parentheses. Okay? Now, curveball. I've given you interval notation. I want you to put it in set builder notation. You cannot go straight from this to set builder. You have to go through an inequality, don't you? Because the inequality is what goes in the set builder. So let's do one together, and then you can do one on your own. So what inequality would this be? Take this and turn it into an inequality first. You did that in A, so now do it in E. So, -5 less than x less than or equal to 2, right? Now that, once you have it as an inequality, then you can just shove it right into set builder, can't you? Domain x such that, I'm going to take my inequality and put it in, boom, -5 less than x less than or equal to 2, where x is an element of what? If you don't know default, we always default to what set? The reals, yes. Okay? So see if you can do number 4 on your own. I'm sorry, F. Why did I say number 4? Oh, because it starts with 4. Write 4 to infinity as an inequality and then put it into set builder notation. Okay? The other reason I record the notes and post them is because if you're one of those people who can't write and learn at the same time, that's fine. Just, you got the notes to go back and listen to if you need to, okay? So what was the inequality? Yeah. X is greater than 4. Starts at 4, goes to infinity. So now, if you didn't get that, can you put it into set builder notation? Domain x such that x is what? Where x is an element of the real numbers. See, it's really not bad, is it? It's not the hardest thing you've ever done. It's just asking to look at things in different ways. You're going to see that a lot in precal where we talk about switching between forms of something, different forms of a function, okay? You've got to be able to make your brain more nimble to be able to go between those forms, okay? Now, exponent rules. Moving on to exponent rules, something you're going to also have to be able to do. Most of you are usually pretty good with these. U to the m power times u to the n power. What is the rule with the exponents? If they have the same base, we do what with the exponents? Yeah, add them, m plus n. Which means that if I have 5 to the 3rd times 5 to the 4th, what do I really have? Yeah, 5 to the 7th. 3 plus 4, right? Okay. Now, if multiplying means we add, then let's use our reasoning sense and tell me what the rule is if we're dividing. Subtract. So my rule would be u to the what? M minus n. Right? So x to the 9th divided by x to the 4th would be x to the what? Yes, 9 minus 4 is 5. All right. Anything to the 0 power. Thank you. Don't say 0. Somebody always goes 0. It's 1. Right? So 8 to the 0 power is, did you say 3? Okay. I had Jesse Pardon last year. He would just say stuff randomly just because I'd be like, 8 to the 0 is, and he'd go 12. I'd be like, thanks, Jesse. All right. I've got him again this year, so we'll see how it goes. U to the negative n. U to the negative n. If anything is to the negative exponent, it does not make it negative u to the n. It makes it, what does the negative in the exponent do to it? Moves it to the denominator. Or if it's in the denominator, it would move it to the numerator. It swaps places in the fraction, doesn't it? So this becomes 1 over u to the n. So y to the negative 3 would be what? Mm-hmm. 1 over y to the 3rd. Good. Okay. Now if we have two things, albeit both being raised to the m power, what do we know? Everything in there gets the m power. So it becomes u to the e to the m. So let's look at this. Number 5, 2z to the 5th power becomes what? Two to the z to the 5th. Now 2 to the 5th power. 2, 4, 8, 16, 32. So this would become 32 z to the 5th. Okay? Now, if we have a power to a power, what do we do with the exponents? We know we don't add them because we've already used that rule, don't we? We don't subtract them. Yeah, we multiply them. So we just multiply this. This becomes u to the v times m. So x to the 2nd raised to the 3rd power would be x to the 6th. U over v to the m power should be treated just like number 5. So what would the rule be? Yeah, apply it to both. U to the m over v to the m. So 2 over b to the 3rd power becomes what? Two to the 3rd, b to the 3rd, and 2 to the 3rd power is what? It's not 9. 2, 4, 8. You were doing it backwards in your head. You were doing 3 to the 2nd power. Okay. Now, sometimes we have to use all of these rules, or just some of these rules. What happens if we have big problems like this? Anybody have any questions so far? Please ask. That is the biggest problem that I have with the first 9 weeks is everybody's like, I'm too scared to ask her a question. What? Did I put 2nd? I'm sorry. Thank you for catching that. And don't be afraid to correct that. 3rd, I'm sorry, to the 3rd. 3rd. Somebody was going, what happened? It's early. It's first day of school. All right, so how do I work this one right here? How do I work example 1 here? Well, obviously the parentheses mean we're multiplying, don't they? So we got to multiply anything we can multiply. So start with the numbers first. What's that going to give me? 10. Now, a and a squared is going to give me what? A to the 3rd. Why a to the 3rd? The rule is that if we multiply with the same base, we add them. So there's an implied what here? 1. So then we're going to take these and we're going to add those exponents. And so we get a to the 3rd, which means we get b to the what? B to the 8th. Now, that's easy enough. Look at this guy number 2 here, though. It's got some negative exponents. Let me give you a hint. You got to take care of those negative exponents first. Move them and then see what you've got, okay? So v to the 2nd is going to have to go where? Down, right? And u to the negative 1 is going to go So u squared is going to stay put, and u to the negative 1 comes up and becomes what? U. In the bottom, we had v cubed, and v to the negative second is going to become v squared. And now we can use our combining rule. So what do we end up with in the numerator? That would be the top. U to the what? Third. Good. And in the denominator, we end up with v to the fifth. Good. Okay? So far, so good? Let's try one more. Get a little more complicated. Last one right here. X squared over 2 to the negative third power. Since all of that is in parentheses, what has to happen with that negative third power? You distribute it basically to both of these. So we end up with x to the what in the numerator? Power to a power, we multiply. And then this doesn't have a power, so it becomes 2 to the... Now we've got negative exponents, so what do we do next? Yeah, we're going to switch them, aren't we? Anything in the numerator goes to the denominator that's negative, and that's got a negative exponent, not negative. If the negative's out front, it does not move. It's only if it's in the exponent. So this thing is going to become what next? This is going to go up. This is going to go down, isn't it? So 2 to the third over x to the... And now we can finish it out. What's 2 to the third? 8 over x to the sixth. Okay? We good with those? We work on them a little bit? Any questions? Okay. Distance and midpoint formula. We're getting there. I want you to know these because we use distance formula a lot and midpoint formula a lot when we get to conic sections. And so it's good for you to know what those are and have them in your head. You also kind of need to know them for the ACT. I know they give you a formula sheet, but wouldn't it be better if you just knew them? Save you from having time. Every minute you take to go look something up is a minute you don't have to work a problem. And they give you 60 problems in, or 50 problems in what, 60 minutes? So it's a lot, 60 problems in 60 minutes. They give you a minute per problem. All right, distance formula. If you have 2 points, x sub 1, y sub 1, and x sub 2, y sub 2, the distance formula is the square root of the difference between the x's squared plus the difference between the y's. Squared. The order you subtract them in does not matter. It does not matter if you take x sub 2, subtract x sub 1, or you take x sub 1 and subtract x sub 2. Just the difference between the two. Can anybody tell me why it does not matter which order you subtract them in? What are we doing after we subtract them? We're taking the square of them, aren't we? What happens to a negative or a positive when you square it? It's positive, isn't it? So does it matter if we take 3 minus 2, what do we get? 1. If you square 1, what do you have? 1. If we take 2 minus 3, what do we have? Negative 1. But if you square that, what do you have? Order doesn't matter in subtracting if you're squaring it. So it does not matter which order you subtract in. So don't be married to that, ooh, it has to be x sub 2 minus x sub 1. No, just subtract the x's, subtract the y's, square them, add them. This is the Pythagorean theorem. Do y'all realize that? This is the Pythagorean theorem. Difference in the x's, difference in the y's. The hypotenuse is the distance between them two directly, right? And we take the square root to get rid of that square. This is the Pythagorean theorem, if you didn't realize that. Midpoint. Midpoint, halfway between, means we need to take the beginning and the end and divide by 2. Again, x sub 1 plus x sub 2 divided by 2. Y sub 1 plus y sub 2 divided by 2. Again, order doesn't matter. Adding is adding is adding. Okay? So let's work one together and then you guys can work one. Let's look at A. Midpoint and distance. Let's start. I always do the midpoint first because it's easiest. Midpoint is another point. Distance is a value. It's a scalar. So let's start with midpoint. X sub 1. So here's X sub 1, here's Y sub 1, here's X sub 2, here's Y sub 2, right? So if we add the X's, we're taking -5 and adding 3 to it, dividing by 2. And we're taking 2 and adding 7 to it and dividing by 2. Does everybody know where that comes from? X sub 1 plus X sub 2, adding those, dividing by 2, adding these, dividing by 2. So -5 plus 3 is what? -2 divided by 2 is what? So -1. And then 2 plus 7. Yeah. So this is -1 and 9/2. And let's leave it as a fraction, huh? If we were going to actually plot this point, we would not plot it as 9/2. We would plot it as 4.5, but leave it. Now, distance formula. Distance here. Oh yeah, we are doing work. Start the way we continue. All right, so distance formula. We're going to take and subtract the x's and subtract the y's, right? So if you want to follow the formula, x sub 2 is 3 minus x sub 1. Be careful. Square it. Y sub 2 minus y sub 1 squared. Why did I say be careful in this first one? If you are taking 3 and subtracting a negative, what's going to happen here? It's going to be a positive, isn't it? So just be careful and put stuff in parentheses like you need to. All right? Don't drop a sign. That will get you in trouble. So this becomes plus. So 3 plus 5 is 8. So we've got the square root of 8 squared plus 7 minus 2 is 5 squared. So what is 8 squared? Yep, 64 plus 25 is square root of 89. This is where we kind of have to think about whether or not it is divisible by anything. In other words, is it a square root we could break down? This is where you kind of need to know your divisibility rules. It ends in a 9, so we would think maybe it was divisible by 3 or 9. We need to really check it and see. Do you know the rule for telling whether or not it's divisible by 3 or 9? Do you remember it? Did anybody ever teach you the rules of divisibility? No, that's for multiplying. The rule of divisibility for 3 or for 9 is if you take the digits and you add them up and that's divisible by 3, then it's divisible by 3. So 8 plus 9 is 17, isn't it? That is not divisible by 3, it is not divisible by 9. That means this number is not divisible by either of those. Okay? If it's even, of course, you note 2. If this is even, it's not divisible by 2, it's not divisible by 3, it's not divisible by 2, it's certainly not by 4. It doesn't end in a 5 or a 0, so it's not by 5. Okay? 6, nope. It's 2 and 3, it's not. 7's the only one we need to kind of check. Goes in 1, 19, nope. So it's not divisible. So we can leave it as the square root of 89. All right? If you know your divisibility rules, it's really quick to check these things. Okay? It's not bad. All right. So let's see. Try find the midpoint and the distance for B. Go for it, guys. Check your work when you're done, please. How'd you do? Did you get them? Now, square root of 34 is not reducible. I know that because it's even, so divide it by 2, you get 17, which is a prime number, so you're done. Is that a skill we need to work on in here? How good are you guys at reducing radicals? Does that need to be a warm-up at some point? Just be honest. And it's not like I'm holding it against you. If it's a skill that you're like, yeah, I could use some work on that, then just say yeah, and we'll work on it. Okay? Any questions? Okay. Next to last thing, equation of a circle. This is probably as far as well, maybe not. We might get all the way through. This is easy. Standard form of an equation. You've done circles before. I know you did in Algebra 2 trig. Standard form of a circle. This shows up. This is the one that really shows up on the ACT too. Is x minus h squared plus y minus k squared equals r squared, where the center is the h and the k. Center comes from here, okay? So the center is hk. Notice it is minus h and minus k, but they come out as positive h and positive k. So they are going to change signs when you pull them out. Okay? They also change signs when you put them in. Radius would be r. So notice, what are you going to have to do to that number at the end there to get r? To get r, you are going to have to take the square root of r squared. It's going to give you r, isn't it? You're going to take the square root of that number. All right, so let's start by actually writing the equation of the circle. So to write the equation of a circle, we know that it changes signs going in. The first number is our h, the second number is our k. And this is my k, okay? Oh, that's nice. All right. So if we want to put this in, it's going to become x what? That's a -4, so it's going to become what going in? It's going to change signs, so instead of minus, it's going to become what? Plus. Yes, so the -4 becomes +4. And then y what? It's a positive one in brackets, so it's going to become what? -1 equals r squared. So if we take r and square it, what do we get? Okay. Well, what if one of them or both of them is 0? What if h and k are both 0? What if only one of them is 0? Do I write x minus 0 and y minus 0? So what is this just going to be? X squared plus equals what? Yeah. R squared, 5 squared is 25. Okay. So we can go one way. Can we go the other way? See, we're almost done. Find the center and the radius of the circle. Can you find the center for me? These are easier to do this direction. What is the center going to be? What are the coordinates of where the center is located? Nope. It's only 0, 0 if it's like C, where you have an x squared and a y squared and no number next to them. Are there numbers with the x and the y? So the coordinates for the center are going to be with those. If they go in and change signs, they come out, they change signs. So what are they going to change to? What is the h for this guy? +5. So this is going to come out and become a +5. And this is going to come out and become what? And then for r, what are we going to have to do to this guy right up here? Square root. What's the square root of 25? So, can you find the center for B? What is the H? 3 or negative 3? Good. And what's the K? 0. Now, R is what? Square root of, which can be reduced. What can the square root of 12 be reduced to? What's the perfect square that's in there for those who don't remember? What times what gives me 12? 4 times 3, right? 4 is a perfect square, so what is the square root of 4? So this becomes 2 root 3. Now, what is the center for C? 0, 0. What is the radius of C? Square root of what? All right. So is there a perfect square that goes into 72? One, 4. Let's see. 9. 9 goes in, doesn't it? Anything bigger? 16, nope. 25, nope. 36, 36 go in? All right, so this is 36 times 2, right? What's the square root of 36? On a day when we have a little more time, I will show you an easier way to do this. If that just doesn't make sense to you, there's an easy way to do the root of anything. Quadratic formula, I think we are going to save for another day, okay? So we are good at this point. We are finished. Its bell rings in like 2 minutes. You have homework to do. Now I am going to amend your homework. If you look at your homework sheet, you need to do all of them except the ones that ask you to solve by using the what? Quadratic formula. I think there were 23 problems on that sheet, which means that you don't have to do, I think, the last 3. So you have what, 20 problems? So 20 problems, you draw yourself a line below 20. Save that for another day, okay? You don't have to do those 3 problems. Now, I won't be here Monday to check the homework, but I will check it on Wednesday, all right? I think you have a reprieve for Thursday. Don't think that that's what you're going to do in class on Monday, though, because Monday in class you're going to have a video to watch and listen to on functions, basic function stuff, and then you're going to have a class with assignments to do that will be used for you. The video is only like 20 minutes, and then you'll have time to work on classwork assignment, and then you'll have homework. Okay? So don't put off. Guys, I cannot stress you enough. I know homework is only 10% of your grade, but here's the thing. I do homework quizzes, and those homework quizzes are 30% of your grade, and those can make or break you. And here's the thing, I let you do. There's probably a homework quiz, right? So when we do warm-up quizzes, I let you use your homework formula. That means that if you've done your homework and you forgot kind of how to do something, you can refer back to your homework to do that quiz, okay? So it's important that you do your homework. That will be the thing that sinks you faster than anything if you don't do your homework, because you are not going to know what you're doing. It is not one of those classes that you just like not do it and still ace the test. Because if it is, you're in the wrong class, you ought to be in either full enrollment or AP. We'll make that move for you. All right. See you guys on Wednesday. Have a great rest of your first day.
flyer and we'll give it a grab.
Yeah. Hi, is it AP Precal? Yeah, sure is. Sit wherever.